Okay, in this video we're going to talk about angular velocity and frequency. Remember that frequency is defined as the number of cycles or revolutions for an object that it makes per second. And frequency is also related to the time period. Frequency is defined as 1 over t, where t is the time period. A rotating object moves through an angular displacement of theta, which is equal to 2 pi r radians in one revolution. The linear velocity of any point on a rotating object is given by the following equation. Be very careful with this. This is something you really need to make sure that you know. Okay, very valuable equation. The velocity is equal to the change in displacement divided by time. The displacement on a circle is 2 pi r over t, and remember this from circular motion. Okay, and we know that 1 over the time period is equal to the frequency f. Okay, so this is something that we have already seen before, this equation right here. We're learning a lot of new equations in this unit. Okay, so we just reviewed that the velocity is equal to 2 pi rf. F is then equal to v over 2 pi r. We know that the speed is defined as r omega. And you can see that the r's cancel out, and you're left with omega over 2 pi. Okay, so that means that omega is equal to 2 pi times the frequency. And we covered this one when we talked about waves. The angular velocity of a rotating object is equal to 2 pi times the frequency of the rotation. Okay, a tire with a radius of 4 meters rolls with an angular velocity of 8.0 radians per second. What is the frequency of the tire's rotations? What is its period? Go ahead and pause the video now. Okay, so let's look and see if you have the correct answer. The correct answer is B. 1.3 revolutions per second, 0.77 seconds is the period. A ball with a radius of 2.0 meters rolls with a velocity of 3.0 meters per second. What is the frequency of the ball's revolutions? What is its period? Go ahead and pause the video now and solve for the answer. Okay, so you should have gotten A, 0.24 revolutions per second. If you take the inverse of that, you get 4.2 seconds. 4 different objects rotate with the following parameters. In which cases are the frequency of the object's revolutions identical? You're going to select 2 different answers here. So go ahead and pause the video and select your answers. Okay, so let's see if you got the right ones. You should have picked A and B. Both of those will give you the same answer. Okay, in the next video, we're going to talk about rotational kinematics.